Good morning, America. The date is June 1st, 2010. I'm your host, Connor Kennedy, here on the DMBN, Dr. Mello's Broadcasting Network. What a wonderful day to start out this month with an amazing report done by Connor Kennedy. Right, Tyler?
Absolutely, Connor. Our top story tonight, a Palo Alto chemist by the name of T. Jeffrey Simons has graciously donated his time to inform the general public, you guys, about his job. Our top reporter, Connor Kennedy, has more. Connor?
Thanks, Tyler. Here I am outside the beautiful house of Dr. T.J. Simons in Palo Alto, California. He was gracious enough to inform us about his job. Shall we go inside and interview him?
Let me give you a little bit about myself. My name is Dr. T. Jeffrey Simons, and I've been in chemistry class for almost a whole year now. I am very qualified to teach every one of you. Good morning, Mr. Connor Kennedy.
It's nice to meet you, Doctor.
Very nice to meet you. Let's start off with the reaction type, shall we?
Viewers have been asking us about a single replacement reaction. Will you explain?
Absolutely, Mr. Connor. So, I've got my orange here, or lemon, whichever one you want to choose, and we're gonna count this as a substance. And what we got is a little metal on the substance. So, single replacement, we're gonna go ahead, take that off, transfer it to the more active metal. Now, we're gonna say that this peach is more active because peaches taste better than lemons.
What about double replacement?
Very good question, Connor. So what we got here is we got our substance and our metal. In this one, we're gonna have our metal as a lemon, and our substance gonna be the lemon, and our metal is gonna be the ocean spray sticker here. On this plum, we've got the plum as the substance. The metal is gonna be our produce sticker here. What happens in double replacement is these metals that are attached to the substances are literally gonna switch spots. So bam, you got your ocean spray sticker on the plum and your produce sticker on the lemon. Double replacement.
I've always wanted to know about combustion.
Combustion? Well, do you have a lighter on you?
Of course.
Wow, thanks, Mr. Connor. So, in our combustion, what we're gonna have is we're gonna have oxygen plus gas is gonna create fire, which is gonna create heat, and it's gonna give off CO2 and H2O. Isn't that interesting?
Finally, on to decomposition.
Very good question, Mr. Connor. You have a filter on you?
Don't even ask.
Obviously. What we're gonna do here, we got our synthesis reaction that we just had. So, what we're gonna do, filter, that's a process to get decomposition. Pour that in there. Bam! Chocolate separated and beautiful clean water here.
Wow.
Yeah, decomposition. Bam! Finish it. Next, we gotta talk about hydrocarbons. Now, when you're dealing with hydrocarbons, you're gonna name them by how many C's they have. Let me break it down for you. 1 C, methyl. 2 C's, ethyl. 3 C's, propyl. 4 C's, butyl. 5 C's, pentyl. 6 C's, hexyl. 7 C's, heptyl. 8 C's, octyl. 9 C's, nonyl. It off with 10 C's, decyl. Yeah, you want a real-life example of one of these? Bam, check it. Propane. Let me introduce you to my pet owl. His name's Esther. He's right in here. Come see. You know what owls say? Yeah, coo, bam, coo.
We need to finish the axis and basis part.
Sorry, I'm on the phone with D-Mills. Just 1 second. No, D. I can bring nachos Sunday. Can Peter Calvin? Can Peter Calvin? I can bring nachos Sunday. Can Peter Calvin? I have them. I have the chips right here. Yes. Yes. Okay, you can't? Okay, well then I'll bring, okay, that's fine. Okay. Oh hey, didn't notice you there. Sorry, I was just talking to D about about nachos, but it's so convenient that I just listed I can bring nachos Sunday, can Peter Kelvin, because I just listed the strong major acids. These acids are very high in H+ and completely dissociate in water. Let's start from the top with I, hydroiodic acid. Next, hydrochloric acid, hydrobromic acid, nitric acid, chloric acid, and perchloric acid. So, let's go over that again. I can bring nachos Sunday, can Peter Kelvin, iodic, chloric, bromic, nitric acid, chloric acid, perchloric acid, bam, finish. Absolutely. Come on over here, let me show you. I have a mystery substance in here, as you can see. Now we're not sure what this is. It's either acidic or basic, but we got our little pH paper here. So I'm gonna dunk that in here. Oh, wow, look at that. Bright red. Let's go over to our universal indicator table, match those bad boys up. It's very acidic. It's got about a pH of 2. There, bam. Finish it.
Thanks so much, Doctor. That was a great presentation.
Absolutely. I'm glad I informed you guys a little bit about the chemistry that we've learned. Come on out. I'll escort you out. Thank you so much for this special report. Now get the out.
Bye. Outside of the doctor's house after a magnificent report where I learned so much. What a good guy. So intelligent, it's amazing. Now let's just sum up what we learned back there, alright? Reaction types, 1. Hydrocarbons, 2. And 3. Acids and bases. And as Dr. Mellows would say, make sure your goggles are on. Back to you, Tyler.
What a wonderful report. I am breathless. That was stunning work by both the doctor and by Mr. Kennedy. This concludes our show. See you next time.